One of the big things that we get out of the squeeze theorem is, yes, we can evaluate the limits of bounded functions, but that's not going to be what we're going to do as much as we are going to use a couple of very special limits of trig functions that come up a lot of times. It gives us a chance to rewrite things when we look at something in the indeterminate form, things like that. Let's take a look and consider the limit as x approaches 0 of the sine of x divided by x. And again, we should try to see what happens with direct substitution. Sine of 0 is 0. Obviously 0 is 0, so I do get this indeterminate form. Now then, I can actually speak to the boundedness of this function. If you want a more detailed proof of what I'm about to say, it does exist. It involves some of your relationships in trig. But I can actually bound this function, and if you want to see it graphically, I would encourage you to do so. But for right now, for the sake of this video, there's kind of a take my word for it element to what I'm about to say. The cosine of x is less than or equal to this function, sine of x divided by x, which is less than or equal to 1. And it's not true for the entire domain, but that is a true statement, at least on the open interval from -2 to 2. And if you recall what we said about our squeeze theorem, it has to be for the interval that includes this value right here, and obviously 0 is on this interval. So the function that I want is bound by these two functions, at least where x is approaching 0. So if this statement is true, and again, you're kind of taking my word for it that it is for the sake of this video, then I can take the limit as x approaches 0 of the lower bound, which is the cosine of x. I can evaluate that through direct substitution. It's equal to the cosine of 0, which is 1. I can also take the limit of the upper bound function, the limit as x approaches 0 of 1. Remember, if I take the limit of a constant, I get the constant back. And so both of these functions right here are approaching 1. And so therefore I can say that the limit as x approaches 0 of sine of x divided by x is equal to 1 by the squeeze theorem. Okay, here's the deal. The proof is a lot less interesting than the actual statement right here. This is a very, very important limit statement that gets made. It's proven using the squeeze theorem. And the proof looks like this, although we should probably, if we were doing a formal proof, establish more about what happened here. But for what we need right now, this is a very, very important limit statement. I usually don't tell students to memorize things, but this one you need to know, that the limit as x approaches 0 of sine of x divided by x is equal to 1. It follows pretty intuitively, just because sometimes it can be reworded a different way. I can take the reciprocal of this, x divided by the sine of x, and it equals the reciprocal of 1, which is still 1. So that's a very important limit statement to know. And we're going to, in fact, in the next video, we're going to use these limit statements to evaluate some limits that we otherwise couldn't have. One more trig limit that we get, so these two really are saying the same thing. The second of these special trig limits that we get is also proven using the squeeze theorem. I'm going to leave it to other proofs to establish that for you if you're interested in that. But the limit as x approaches 0 of 1 minus the cosine of x divided by x. And again, you can see we get the indeterminate form here. Cosine of 0 is 1. That zeroes out the numerator. The denominator would be 0. You can establish that this actually equals 0, which is shown. So this can be shown using the squeeze theorem. I don't want the focus on this particular lesson to be the proof of it. I want to get into us using these particular limit statements next. But But these limit statements are very, very important to us. They all can be shown using this idea of the squeeze theorem, and in the next video, I'm going to use these statements right here to evaluate some other limits involving trig functions. So definitely know these as you move forward, because they will help you evaluate some limits of trig functions in the future.